In this video, we are going to talk about the measures of variability in quantitative data. Variation measures the amount of dispersion. The measures of a center tell us nothing about the variability of the data. Recall that there are three common measurements of center. The first one is sample mean, denoted as x bar, which equals to summation of all data divided by the number of data. Second one is called median. Third one is mode. First measurements we are going to learn is range. Range is the difference between the largest and the smallest value. These measurements give no indication of how the values are distributed between the max and the minimum. The formula of the range is use the maximum value subtract the minimum value. Is range affected by the outliers? Yes, this looks like the formula here. Because the calculation of range involves the extremely large and extremely small values. In other words, the range is not resistant. Here is the example how we can calculate range. So the first step is to find the maximum value in a theory or in a data set. So in this data set, 9 is the maximum value. And we are going to find the minimum value. It is obvious that in this data set, 1 is the minimum value. So the range equals to the maximum value 9, subtract by the minimum value 1, and it equals 8. The correct interpretation for range in this data set is that the number of points varied by 8. Next, we are going to learn variance and standard deviation. You must understand what a deviation is before understanding those concepts and measurements. Deviation is the amount by which a single measurement differs from a fixed value, such as the mean. The variance and the standard deviation will provide measurements that involve how far away each observation falls from the mean. For example, how much each value of x deviates from the mean of the dataset. Variance provides the average of the squared deviation over each observation from the mean. There are two formulas we can use to calculate the sample variance. The first option is the best at explaining the concept. Remember that variance measures how far away each observation falls from the mean. The second option has its advantage too. It is easiest to calculate by hand. You need to pay attention to the notation used here. S squared equals the sample variance. N here is the sample size. The summation of x subtracted by x bar squared is the sum of all the squared deviation. You also want to remember the order of the operations. First, you want to take x subtracted by x bar, then x subtracted by x bar squared, then summation all those together. Issue with the variance is that it is hard to interpret because we are dealing with the squared deviations. Therefore, we must take this one step further and calculate the standard deviation because it is easier to interpret. Standard deviation is a measurement of the area scattered around the mean. It is the typical or average distance observations fall from the mean. The formula is very similar. It just equals to the square root of a square of s squared. So this is the option 1, and this is the option 2. It is very similar to what we saw from the last page. Sample standard deviation is denoted by is here. The larger the standard deviation is, the greater the variability of the data is. If the standard deviation is 0, then all the value in the data will be the same. In this example, we are going to calculate the variance and the standard deviation for the following values. The sample size is 12. Recall that the sample mean is calculated as, which is the summation of all data we have, and subtract by the sample size. The sample mean is 6. You can verify this by yourself. Then we are going to calculate the deviations. The 1 here just equals to 7 subtract by 6, and so on and so forth. There's a handy trick you want to remember. If your summation of the deviations is not 0, it means your calculation is wrong. You have to double check your calculation before you do the next step. Okay, I'll repeat. If the summation of your deviation is not 0, it means you did something wrong. You made mistake somewhere, and you have to redo what we have done so far, and do not proceed to the next step. Then we are going to calculate the squared deviation. The 1 is just equals to the square of the deviations here. Same thing here. And the square of -1 is still equal 1. 4 equals to the square of 2, and so on and so forth. One thing you want to pay attention to, the squared deviation must be positive. If you have a negative value, it means your calculation is wrong. Then we are going to calculate the sum of the squared deviation. The 46 here just equals to the summation of 1 plus 1 plus 1 plus 4 plus 1 plus 1 plus 1 plus 9 plus 0 plus 1 plus 25 plus 1. You can verify this by yourself. Then we are going to calculate the variance or sample variance. So remember that the 46 comes from here, the sum of the squared deviation. The 12 here is sample size. And we will adjust the denominator or the sample size by subtract 1. The formula for standard deviation is s equals the square root over squared s. So you have to find the variance first to calculate standard deviation, which you can verify this calculation by yourself. The square root of 4.1818. The correct interpretation will be the average distance of observations from the mean is 2.05. Here I'm going to show you how to use option 2 to calculate the standard deviation. The first step is we want the square root of all x here. So the 49 equals to 7 times 7, and 25 equals to 5 times 5, so on and so forth. Then you want to add all s squared in this row, which is 49 times 49 times everything else. The last two is 1 and 49. This is denoted as sum of s squared. Then we want to calculate the summation of x, which is 7 plus 7 plus 5, everything else, the last two is 1 and 7. This should equals to 72. In step 4, we determine the sample size, which is 12. In the last step, we can use the formula here to calculate the standard deviation, which equals to the summation of x squared, which is 478, subtract by the 72 squared, divide by sample size 12, and divide by 12 subtract 1. You can do the calculation by yourself. You will get the same result as we do from here, 4.1818. Please verify this calculation by yourself. Note that if the maximum number of pounds was 15 instead of 9, then the standard deviation would have been affected. The sum of squared deviation will be 115, not 46. So we will use 15 instead of 9 here. And we just do the same calculation as we did in this page. Then you can verify that the sum of squared deviation becomes 115, not 46 anymore. Then we can calculate the sample standard deviation. It becomes larger, which is 3.23. Hence, we know that standard deviation and variance are affected by outliers, thus they are not resistant.